The question on page 250 at the top, number 3, how would the equation change if 0, 5 were used for x2, y2 and 2, 13 were used for x1, y1 in the slope formula? Well, here's what we did originally. And we said that this was x1, y1 and that this was x2, y2. And here's what we got when we did the formula that way. If we had decided that this one was x2, y2 and this one was x1, y1, then we would have put it into the slope formula this way. But you just get a negative over a negative, and the quotient is still a positive 4. So either way, you get the same slope. Okay? The only thing about calculating slope is you just need to make sure that you don't mix and match, that you don't put like a y2 minus y1 and then on the bottom you do something like x1 minus x2, because that's not okay. It's got to be y2 minus y1 over x2 minus x1, or it's got to be y1 minus y2 over x1 minus x2. They've got to both be kind of paired the same way. All right, your turn. Write the equation of each line in slope-intercept form. So why don't you do that, pause, see if you can do that, and then hit play and check your answers for 4 and 5 in just a minute. All right, if you're having a little trouble figuring out what to do, I'm going to remind you that number 4 is just like example 1A on the previous page. Number 5 is just like the example 1B on the previous page. So take a look at those and see if you can figure these out. All right, so following the example on the previous page, you're trying to get it into slope-intercept form. You're going to take that point, the x and y value, the y value goes where y was written, the x goes where the x was written, the -1 goes in there for slope, so you have 2 is equal to -3 plus b, and then obviously you're going to add the 3 to both sides to move it, and so b is going to be equal to 5. And then you're just going to write your equation. Y is equal to m, which is -1, x plus b, and b is 5. All right, on number 5, I have to start out by finding slope. I decided that this is x1, y1, this is x2, y2. So we're going to do y2, which is 18, minus y1, which is 4. So 18 minus 4 divided by x2, which is 3, minus x1. So I have 18 minus 4 is 14, and 3 minus 1, which is 2. 14 divided by 2 gives me a slope of 7. And then I am basically back to this set of steps. Okay, I just had to find the slope first. All right, so I'm going to kind of squeeze this in here. So I want to put everything into y equals mx plus b. It doesn't matter which point I pick. I'm just going to go with this one. So I'm going to put 4 in for y, 7 in for slope, 1 in for the x, to get my b. So 4 is equal to 7 plus b. Subtract 7. b is -3. Ooh, and I'm running out of room. I'm going to come back up here and write it. So y equals 7x, and then my b is -3. -3. Okay, so this just requires one extra step. You have to find the slope, and then you go through the same set of steps as this one. All right, now I'm down towards the bottom of page 250, and I'm looking at example 2a and example 2b. So first, write each equation in slope-intercept form. It looks like that one's already in slope-intercept form. This one we'll have to write in slope-intercept form, but this one's already in slope-intercept form. So the slope is 5. It's right there where it's got the m in the formula, y equals mx plus b. The y-intercept is -4. So I know that the y-intercept is going to be wherever it crosses the x-axis, so that's 0, 4. And so literally I just start with that point, 0, 4, and then the slope is 5. So I just go up 5 over 1, put a point. Up 5, over 1, put another point if I had that much room on the graph. So here's a point, and then the slope tells you to go up 5 units and over 1 unit. Okay? Up is positive, to the right is positive. So that's positive and positive because you have a positive slope. Okay? Okay, for B, the equation actually starts in standard form, and again, we'll talk more about standard form in the next couple of lessons. We've already touched on it, but here it is again, ax plus by equals c. So we want to write it in slope-intercept form. We want to write it in the y equals mx plus b format. So I've got to subtract 2x from both sides. Okay, so I get 6y is equal to negative 2x plus 6. That's after I've subtracted the 2x. And then I have to divide both sides by 6. So I get y is equal to, well, I have to do negative 2 divided by 6, and I have to have 6 divided by 6. So that's going to be negative 1/3 x, and then 6 over 6 is 1. So your slope is a negative 1/3, and your y-intercept is 1, or if you wanted the ordered pair, it's 0, 1. Okay? All right, so you're going to plot 0, 1, 0, 1. And then you want to move 1 unit down, because look at your slope, and 3 units to the right. So I'm going to use 1 unit down and 1, 2, 3 to the right. I could also do another point by doing the opposite, going up and to the left. Okay, and then draw a line through the points. Okay, so there's my line. Make sure that if it's a line, they haven't specified a domain, so you can assume that it's all real numbers, and so you should draw arrows at the end of your lines. All right, so now we're going to move over here, and it's your turn. These are just like the example from 2B on page 250. Okay, so take a minute and make an attempt at those, and then hit play and check your answers. All right, after I've taken it out of standard form, I rearranged it a little bit so that I put it into slope-intercept form, which is right here. My y-intercept is 0, 4, so 0, 4. There's my first point. And then the slope tells me to go down 2 and to the right 1. So down 2 to the right 1. Down 2 and to the right 1. And I can keep doing that all day long. Down to the right 1. Okay, and then connect your points. All right, number 7 is also in standard form. So we're going to subtract 2x from both sides, and that's going to give us 3y is equal to negative 2x plus 6. Then I've got to divide everything by 3. Y is going to be equal to negative 2/3 x plus 2. All right, so we're going to start with the y-intercept. B is 0, 2. That's right there. 0, 2. And then the slope tells me to go down 2 and over 3. So down 2 and over 3. Or up 2 and to the left 3. And then connect your points. All right, I'm now towards the bottom on page 251. Example 3 says to identify the slope and y-intercept of the graph that represents each linear situation and interpret what they mean. Then write an equation in slope-intercept form and use it to solve the problem. All right, so for the most part, A is done for you, but let's go ahead and walk through it so that you understand what they did. For one taxi company, the cost Y in dollars of a taxi ride is a linear function of the distance x in miles traveled. The initial charge is $2.50 and the charge per mile is 35 cents. Find the cost of riding a distance of 10 miles. Okay, so first of all, they kind of already told you this, but your independent variable is the number of miles that you go. So that's going to be your x. Your dependent variable is the cost. So that's going to be your y. So if you just get into the taxi before they even take you anywhere, you're going to pay $2.50 for basically the privilege of putting your rear end in the taxi cab. Okay? And then they're going to charge you 35 cents for each mile you go. All right, so the cost is going to be 35 cents per mile plus that $2.50 flat rate. So to find the cost of riding a distance of 10 miles, you're going to substitute 10 in for x, because remember, miles we said was the x. All right, and then you're going to find the y. So 0.35 times 10 plus 250. Okay, and that gives you $3.50 plus $2.50. So it is going to cost you $6 to go 10 miles. Okay, and that's what they say down here basically.